Hello everyone, my name is Pibin Abram and in today's video we will talk about friction. So without wasting any more time, let's get started. Okay, so let me start with Newton's first law of motion, which is like very famous law and we all know it, right? So what is this Newton's first law? It states that whenever there is a body at rest, then it will tend to remain at rest, and whenever the body is moving with some constant velocity, then it tends to move with that constant velocity until and unless there is an external force which is there to change its state, right? So mathematically it's pretty simple. If there is no net external force, if the net external force acting on the body is zero, then there will be no net acceleration of the body. That is what mathematically Newton's first law of motion states, right? It's pretty simple, right? For example, it simply says, for example, if this ball, let's say I have a ball, right? And this ball is moving in this particular surface. Just a minute. So let's say this ball, yeah, okay. So now this ball is moving with some constant velocity in this particular surface. Then unless I apply a force, unless I apply a force to stop it, it is not going to stop. It is going to move, right? With that same constant velocity. That is what Newton's first law of motion states, right? But now I would like to ask you a simple question. In reality, if you leave a ball moving with some constant velocity v, will it be moving with that constant velocity, or after some time it actually stops? Yes, your answer is that after some time, this ball is going to stop, right? This ball is going to stop. Now, what actually happened? Obviously, it can be somewhere here. Let's say the ball stopped here. Now, the question is, what happened? Let's say ball came to rest at t is equals to some t. At this place, ball came to at rest. Ball is at rest, right? Now, the question is, what happened? What happened, right? Now here I'm assuming that air resistance in its path, air resistance is actually zero. I'm assuming this, that there is no air resistance. So if there is no air resistance, then what happened? Why did the ball stop? Why did the ball changed its motion or its state, right? The answer to that question is, according to Newton's first law, it can change the state, right? It can, for example, if a car is moving, it can stop. If, for example, if car is at rest, it can move if you apply a force, right? So if, let's say, if there's a Superman, standing over here, right, and he applies a force to stop the car will stop. Yes or no, right? Very similarly, if there is some really strong person who actually pushes this car with some force, this car will start moving. Is that a yes or no? So very similarly, in this example, the ball is stopped here, right? Now, ball is stopped. According to Newton's law, the ball will be stopping if there is an external force, right? And what is that external force? So that means the ball was moving with this constant velocity in the forward direction, but there must be some force which is actually stopping the ball, right? Now, that's force, after lots and lots of experimentation, the scientists were able to find out that there is a force because of the point of contact between the surface and the body, right? Because of that point of contact, there is a force which is basically opposing the motion, and that force is what you call as your force of friction, right? This force of friction is actually the external force which is opposing this particular motion. I hope you guys can understand that, right? Okay, so let's try to understand what actually is this frictional force, right? Okay, so basically, what is friction? Firstly, it is a contact force, just we have discussed, right? For example, if I take one more here, for example, let's talk about this. So basically, if I zoom it here, there is a contact. You guys can very nicely see there's a contact here, right? The ball is in contact with the surface. Now, because of this contact, what happens in reality, the surface is not very smooth, right? Surface is rough. Even this surface is also rough. It is not perfect circle, right? So when the surface travel like this, so because the roughness of the surface, there will be resistance offered in the flow of object, right? So because of that, what happens? right? Because of that, the motion is basically opposed, and we call that force as frictional force, right? We call that force as frictional force, right? I hope you guys can understand. Very important point, that it is a contact force. If there is no contact, there will be no friction. I hope you guys can understand that, right? Okay, next property, it is a force which opposes the relative motion of the, or the tendency of relative motion between two bodies. Yes, very important point. It opposes the relative motion, right? It, see, mostly we say that it opposes the motion, but the real, the real definition is it opposes the relative motion or the tendency of relative motion also, right? So when I say tendency of relative motion means, you can actually apply some force, but the body is not moving. So again, if the body is not moving, then again there is a frictional force which is like opposing you, right? So it opposes the tendency as well as the relative motion of a body or between two bodies, right? Okay, great. It acts tangentially along the contact, right? So basically, let me just give an example. Again, same thing. So if we have this, right? So body is moving with some velocity v, but the frictional force will act tangentially along the contact. There is this tangentially along the, this is your frictional force. Let me call it F. Normally represented by small f, right? So this is your frictional force which is acting tangentially along the contact, right? Okay, now let's try to understand what do we mean by relative motion here, right? So let's say I have, examples here. So I have one block, number one block, I have number two block, right? And let's say somebody is applying some force F on your number one block, right? And because of that force F, right, the block 1 is basically moving with some acceleration a, right? Now we have studied relative motion means with respect to each other, right? Okay, now let's say you are here, right? You are at block 2. So when you are at block 2, standing on block 2, and when you observe your block 1, when you observe your block 1, what you see, your block 1 is moving with some velocity towards right. Is that a yes or no? What you will observe is your block 1 is actually moving with some velocity v in the right direction, right? Now there is a motion, right? So when you see that there is a motion, there will be a frictional force along the contact tangentially which will be there to oppose that. So let me call that friction F, frictional force acted on your 1 because of your surface 2. Yes or no? Okay, great, that is very great. Now let's say you have changed your frame of reference. Let's say now you are standing on your block 1, right? So when you are standing on block 1, what do you observe? You will observe that your block 2 is moving in that direction. I hope you guys can understand that, right? Again, the motion, in reality the motion is done by block 1, but when you are at block 1, right, you are at block 1, and from block 1 when you observe block 2, you will see your block 2 is moving in that direction, right, with the same velocity as that of your block 1. Is that a yes or no? So the moment you see a relative motion, again tangentially at the point of contact, you will see a frictional force, right? And let me call that frictional force which is acted on your block 2 because of 1. So basically this is how you can understand how the friction is actually opposing the relative motion. So relative motion means the motion with respect to each other, right? So for example, if your frame of reference is on your second block, then you will see that your block 1 is moving with the, with some velocity v, so the frictional force will oppose it. For example, if you are at block 1, you will see your block 2 is moving in the opposite direction with same velocity, so it will oppose it tangentially on the point of contact. I hope you guys can understand that. Yes, okay, great. So let's try to understand. There are basically two types of friction. Number one is your static friction, another one is your kinetic friction, right? As the name suggests, static friction means when the body is at rest, right? That means the friction that will be, applicable when the body is at rest. And the second one is your kinetic friction, that is the friction that will be applicable when the body is in motion. Is that a yes or no? Very simple. So this is a friction that comes to play when there is a tendency of relative motion. Yes. So body is at rest, but obviously when you apply a force, there will be a tendency of body to move, right? So when that tendency is there, then the body is going to experience a friction, which is basically called as the static friction, right? On the other hand, when we have kinetic friction, so this friction comes into play when there is a relative motion. So the moment you have applied enough force for the body to move, then at that time the friction that you experience is what you call as your kinetic friction. I hope that is understandable, right? Let me give you a simple example. Let's say, assume that your mother asked you to move certain almirah at your place to some other location, right? So for example, you have this almirah, right? Let's say cuboidal almirah, which is quite heavy, right? Okay, so let's say you want to move this almirah from let's say A position to some B position. You want to move this, right? Okay, so the first step is that obviously you will observe the almirah, and then you will figure out how much force I must apply, right? So what you will do first, you will apply little bit of force, right? You apply some force, right? The moment you apply some force, you will experience, okay, this much force is not enough, I need to apply more force, right? So let's say you have applied some F1 force, right? So with that F1 force, the almirah is not moving at all, right? So what you will do, so basically what is actually happening here is this almirah is in contact with the flow, right? I hope you guys can understand that. Okay, let me just draw that again. This almirah is in contact with the floor, right? Okay, great. Let me, yeah, now it's fine. Yeah, so this almirah is in contact with the floor, right? So you have applied some F1 force, almirah is not moving, right? That means what is happened here, you have applied the force. What happened to the force? The force is there, but you have to understand, because at the point of contact there is a frictional force. Now basically you can see your almirah is at rest, it is not moved, so there is a tendency of relative motion, right? So at this particular time you will experience a static friction. So there will be a F static, so there will be a static friction which is like opposing, which is like cancelling out your F1 force, right? Again, let's say you have applied some more force. Let's say you have applied F1 plus some del F force, right? So the moment you have increased your force, what happened, you see that your almirah is start moving. The moment almirah starts moving, at that particular time, your friction will not be static anymore, it will be kinetic friction, right? At that time you will see, instead of static friction, you will be experiencing kinetic friction, right? I hope you guys can understand that, right? So your static friction will be applied when there is a tendency of relative motion. Remember, the body is not moving, there is a tendency, right? So at this particular time we will apply, the friction that is applicable is what you call a static friction. The moment the body has started moving, at that particular time the friction is what we call as our kinetic friction, right? I hope you guys can understand. Let's try to understand these frictions in detail. Let's start with kinetic friction, right? Okay, so the kinetic friction, which is represented by small f k, right? Let's try to understand what are the condition at which your kinetic friction will be applicable. Number one, there must be relative motion, right? So kinetic friction will only happen when there is relative motion. It is a constant force, or it's a constant friction force, right? Very important, it is a constant force. See, when we talk about a static friction is not considered as a constant force of friction, because it keeps on changing, it keeps on adjusting itself. On the other hand, your kinetic friction is a constant force. That means it has a constant value. That means 2 Newton, right? For example, 2 Newton is the kinetic friction, right? So so body will be opposing the external force with this 2 Newton force, right? It will not change, it is a constant, it has a constant value, right? Okay, great. Third one, uh, Direction of kinetic friction will be such that it will oppose the relative motion between the bodies. Yes, obviously, let's say I have the surface, I have on the surface, I have this, mass m1, right? So let's say you have applied some force, right? External force. Because of that external force, the body is moving with some v velocity, right? Now you have to understand the friction will be tangentially in the opposite of that relative motion. So basically your body is moving with this, in the forward direction. So basically your body is moving in the forward direction, so the frictional force will be in the opposite direction, right? This is the frictional force here, that is F kinetic. I hope you guys can understand. The direction of frictional force will be such that it will oppose the relative motion, right? Okay, great. Now how you can find out the value of this kinetic friction? So this is experimentally proved that your kinetic friction depends only on one thing, that is your normal reaction. What is your normal reaction? You guys can see in this particular example. So basically the gravity will be attracting this, mass m1 with this particular force m1 times of g, and in response to that the surface will apply a normal. Yes or no? Right? So this normal reaction, so basically your kinetic friction depends upon this normal reaction. I hope you guys can understand, right? Okay, so your kinetic friction is proportional to your normal reaction. This is experimental result, right? And obviously whenever you take out the proportionality sign, there is always a constant that is coming. So your kinetic friction, that is your Fk, will be given as a constant of proportionality nu k times your normal reaction. This nu k is termed as coefficient of kinetic friction, right? This nu k is known as coefficient of kinetic friction. Now this basically is a constant which depends on the surface, right? So from surface it depends. So it is basically the property of the surface. I hope you guys can understand, right? We'll try to understand, we'll try to make it more understandable with this simple example, right? So let's try to do this. So the question is that I have a block of 3 kg mass which is kept at a surface. The surface has friction, right? Okay, so the surface nu k, that is coefficient of kinetic friction for the surface, is given as 0.2. It is given, right? It is 0.2, right? Okay, great. So the coefficient of kinetic friction is given. So there is a force which is applied at this particular angle. It is making an angle of 45 degree with the horizontal, right? The force is 10 Newton, right? Okay, great. Now the question is, you're supposed to find out the value of normal reaction, then find the value of your kinetic friction, then find the acceleration of the block. All right, so let's try to do it one by one. The first and the important thing, we will just simply we'll simply see what are the forces that is acting here. So obviously there is a force F, so I can make the component of this force F. One component will be in this particular direction, that is F cos of 45 degree, and then one will be perpendicular to that 3 kg mass, right, which is F sine 45 degree. Yes or no? Great. Obviously the earth will be attracting this with 3 times of g, and there will be a normal reaction in response to that, right? So let me very quickly make the free body diagram here. So let me just make the free body diagram. So I will assume my 3 kg mass as point like, right? Then I'll apply all the force that is acting on the body, right? Okay, so 3g is in the downward direction, normal reaction is in the upward direction. There is F sine 45 in the upward direction, and there is F cos 45 in that direction. And also you guys can see, obviously there is this force 10 Newton applied. Obviously because of that 10 Newton, body will move with some velocity and there will be a acceleration too, right? So there will be a frictional force opposing it. Yes or no? Let me call it Fk, right? Is that a yes or no? So let me just write it here. There is Fk, that is frictional force, is also there, right? Okay, great. Now let's try to find out. First thing is we need to find out the value of normal reaction, right? So from this obviously there is this acceleration happening here. So from this free body diagram I can simply say, if I talk about the vertical components here. So I have this vertical component, and vertical component are in equilibrium, right? Because nothing is happening, right? There is no vertical, movement here. So basically vertical components are in equilibrium. So I can simply write n plus f sine 45, right? That is basically this one, right? N plus f sine 45, that must be equal to 3 times of g. Yes or no? That must be equals to 3 times of g, right? Is that a yes or no? I do not know the value of n, plus I know the value of force, that is 10 multiplied by sine 45 is 1 upon root 2 is equals to 3 times of g. G is, let me take it 10 meter per second square. This is 3 into 10, right? Or it will be simply equals to n plus 10 root 2 is equals to 30. Yes or no? Or you can simply say n is equals to 30 minus 10 root 2. Or you can simply say n is actually equals to root 2 30 root 2 minus 10, right? Just rationalize it, multiply root 2, both denominator and numerator, you will get, you have root 2 here, I have 2 here, so this will be n is equals to 30 into 2 minus 10 into 2, right, divided by 20. Or simply I can say my normal reaction is actually equal to 30 minus, yes, this will be 5 root 2, yes. So this is the normal reaction. 30 minus 5 root 2 is the normal reaction, right? So I got the value of normal reaction here. Next thing is I need to find out fk, right? So from, if you remember, this is the formula to find out the value of fk. So fk is nu k times of n, right? So let me try to find out here. Fk is actually equals to nu k times of n. I know the value of normal reaction, right? So I'll just simply write Fk, and I also know the value of nu k. It's given. Nu k is 0.2. Let me just put it there. 0.2 into normal reaction is, yes, 30 minus 5 root 2. All right, great. So from here I can say Fk is actually equal. So this is 2 upon 10 multiplied by, this will be 30 minus 5 root 2 into 2 upon 10. Yes or no? All right, this will be cancelled out, and this is 5 2 2 2. Okay, so your fk is coming out to be 6 minus yeah, 6 minus root 2. I hope I didn't do any mistake, right? Okay, 6 minus root 2 is your frictional force. I hope you guys can understand, right? Great. Now we are able to find out the frictional force also. Now find acceleration of the block, right? Now you guys can see here there are two forces. There is this F cos 45 and there is this frictional force, right? And we simply know this F cos 45 is more because there is an overall acceleration in the forward direction, right? So I can simply write F cos 45 minus Fk is actually equals to mass times of acceleration by Newton's second law of motion, right? So I can just simply write it here. So the third part, that is for acceleration, I can write my F sine 45. Is it sine or is it cos? It's cos. Yeah, sorry, I'm really sorry. This is F cos 45, right, minus of Fk, that is equals to mass times of acceleration. This is by second law of motion. I hope you guys can understand that. Yes, okay, great. So your f is 10 and your cos 45 is 1 upon root 2 minus fk. The value of fk is already known to me. This is this one, 6 minus root 2, right, is equals to mass is basically known to me, that is 3 times of a. All right, great. This is 10 root 2. This is minus 6 plus root 2 is equals to 3 times of a. Let me take root 2 as LCM. I'll take root 2 as LCM. This will be 10 minus 6 root 2 plus 2, right? And that is equals to 3 times of a. I'll multiply with root 2, in the numerator and denominator, you will get, yes, this will be 10 root 2 minus 6 into 2 plus 2 root 2 upon 2, and 2 is multiplied over here. This will be 6 times of a. So from here, let me just solve it further here. This will be, yes, 12 root 2. Okay, great. 12 root 2 minus 12 is equal to 6 times of A, or simply you can see I'll take 12 common. This is root 2 minus 1 upon 6, right? This is 6 2, or simply this is 2 multiplied by, yes, this is 1.41 minus 1 is equals to A, or simply equals to 2. This is 0.41, right? You will get the answer from here, right? So this is acceleration is actually coming out 2 multiplied by 0.41. This is meter per second square. We can find out the value here, right? I hope you guys can understand how to find out the value of acceleration here, and I hope you understood how we can find out the value of Fk, that is your kinetic friction, the value of kinetic friction. Is that a yes or no? Right? I hope you guys can understand that. Let's move on to our next topic, that is static friction. Very important. So as we all know, static friction only comes into action when there is a tendency of motion, and in reality there is no motion, right? This friction acts when there is a tendency of relative motion, right? Okay, great. Body will be at rest. Yes, the body will not move, it will be at rest, right? And very important, it is a self-adjusting friction, right? There is no specific value for it. It is a self-adjusting friction. Let me explain why we call it as why we call it a self-adjusting friction, right? Okay, now let's take an example of the almirah. Let's say this is the almirah that we talked about. So your mom asked you to move this almirah, right? So what you did, you have applied some force here, you have applied some F1 force here. So because of this F1 force, the almirah is not moving at all, right? So what is actually happening here, as almirah is not moving, but there's a tendency of relative motion in the almirah, so there will be a frictional force which will be acting here, which we call as your F static, Fs friction, right? So you have applied this F1 force, and this F1 force is is being cancelled because of this friction that has been experienced by the body, right? It is happening because their body is in contact with the surface. I hope you guys can understand, right? So let's say you have increased your force to some del F, right? And even after increasing the force, again your almirah is not moving. That means this this friction has now increased its value, right? So it is basically adjusting itself, right? Again you have improved, you have increased the force here. Again you'll see the the almirah is not moving. That means again this frictional force has adjusted itself. I hope you guys can understand, right? So basically we call it a self-adjusting frictional force. Why? Because it depends upon how much external force you're applying, right? So for example, there is a block and you're applying some force, but as you're applying this force, what is happening? The block is not moving. That means there is a frictional force which is not making the block to move. Again you have increased the force. Again the frictional force will also increase itself so that this block should not move. Yes or no? I hope you guys can understand. But again, it cannot do it forever, right? So as you increase, there will be a limit. There will be a limit, right? So the moment it crosses that limit, the block will move, and the moment the block moves, the static friction is no more. The friction that we will be talking about will be the kinetic friction. I hope you guys can understand this concept. Yes or no? So basically it is a self-adjusting frictional force, right? It adjusts itself depending upon how much applied force we are applying here, right? Yes, so like I said, it will adjust itself until it reaches a limit, right? That limit is what we call as your F limiting, and that limit is what we call as your F limiting, or the maximum value of static friction, right? So that limit is what you call as your F limiting force, or the maximum value of static friction. I hope you guys can understand, right? So your static friction has a range over here, so it's the minimum value of static friction will be 0 and the maximum value will be F limiting. So basically you have to understand the frictional force take the value of your external force in this particular range, right? So if your if it is, so basically let me just take out this particular part. So in this particular range, let me just take out one more 0 here. Yeah, so in this particular range, you have to understand, in this particular range, the frictional force, the static frictional force take the value of external force, right? Can you guys understand that? For example, let's say you have a block, right? And you have applied a force here, 10 Newton. And let's say the moment you have applied 10 Newton, the block is not moving, right? That means there is a frictional force which is like stopping it. So if it is not moving, that means your frictional force is actually equals to 10 Newton, right? So basically it has taken the value of external force. I hope you guys can understand. Now this will only happen in this particular range if it is less than F limiting and if it is more than 0, right? But the range at which your static friction acts is if it has a 0 value, and if it is actually at the limiting point also it will act, right? So I hope you guys can understand, right? So at F limiting or at the maximum value of static friction, right, it has a value which is known as your newest times of your normal reaction, which is very similar that we have studied in your kinetic friction. So here this nu is what you call as coefficient of static friction or coefficient of limiting friction, right? Okay, I hope you guys can understand that. And the direction will always be is such that it will oppose the tendency of relative motion. No, that is something which we already know. Now let's try to understand this with a simple example. Okay, very good. The example is, you guys can see over here, I have a block of 1 kg. I have a block of 1 kg which is like kept at a surface, all right, and a force of 1 Newton is being applied. So a force of 1 Newton is applied. I have no idea whether the one more thing is given, that is nu s, the coefficient of static friction is given to me, that is 0.2. Now I have no idea whether with this force the block moves or the block is at rest. I have no idea. I have to find that out, right? And I can find that out. I will tell you how we can find that out. So the question is, find frictional force and acceleration of the block, right? We have to find the frictional force. Now it is not mentioned over here whether we are talking about kinetic friction or static friction, right? So the simple explanation to this is, if this block moves, then we are talking about kinetic friction. If this block is not moving, then we are talking about static friction. I hope you guys can understand. Acceleration, if this block is moving, then there will be acceleration. If this block is not moving, then there will be no acceleration, right? Yes or no? So basically right now I'm clueless whether this block moves or not. Now how I can find out whether this block is going to move or not? Now I can find that out by finding F limiting. So if I can find out the value of F limiting, right? So if I can find out the value of F limiting, and F limiting value is basically more. Let's say F limiting value is basically more. Let me just write that down. F limiting value is basically more than my F applied. At this particular condition, what is going to happen? Your F limiting is more. That means body is at rest. Yes or no? Body is at rest, right? If the body is at rest, so I can simply say my here static friction will be applicable and static friction will be equal to my F applied. I hope you guys can understand. On the other hand, if your F limiting is basically less than your F applied, at this particular case, body is in motion. Can you guys understand that? In this particular case, body is in motion, and in this particular case, what is going to happen? You have to understand. In this particular case, your frictional will be F kinetic, not your static friction. I hope you guys can understand. The first and the foremost important thing I have to do in this particular question is I have to find out the value of F limiting, right? So how I can do it? Let me just first see what are the forces acting here. So 1g is acting here. There will be a normal reaction in this particular case. So basically I can make the free body diagram here. So this is your point mass. 1g is in the downward direction. There is this normal reaction here, and there is this F is equals to 1 Newton. Now there will be a frictional force. Now I have no idea whether it will be kinetic or whether it will be static. So let me just find out that. So first thing is I have to find out the value of F limiting, right? So F limiting, from our theory, I know I can find out with this equation. F limiting is equal to nu s times of n. Okay. All right. So F limiting is actually nu s times of n. Right. So in order to find out F limiting, I need to find out the value of n, and nu s is already given to me in the question. Yes, it is given 0.2. Right. So let me just find out here. So you guys can see from this free body diagram, I can simply see there is no vertical movement, right? So if no vertical movement, so your normal reaction will be equals to 1 times of g, or this will be normal will be equals to 1 times of 10, or normal will be equals to 10 Newton. I hope you guys can understand. So normal reaction is 10 Newton. I'll just put that here. This will be nu s has a value of 0.2, right? So I'll put that here. 0.2 multiplied by 10. The value is coming out to be 2 Newton. So F limiting, the maximum value of your static friction is basically 2 Newton, right? So you have to understand here it can take maximum value up to 2 Newton. This is F static max or F limiting, right? So you guys can see F limiting, this is the case here. F limiting is greater than F applied. That means body is at rest. I hope you guys can understand. Body is at rest. So if the body is at rest, that means your F static will take the value of the applied force. So what is the frictional force over here? It's basically 1 Newton. It will take the value of F applied force. I hope you guys can understand that, right? So if the body is at rest, then what will happen to the acceleration? Acceleration will be equal to 0, because the body is not moving at all. I hope you understood the concept. Is that a yes or no? Right? Okay. So I hope you understood the concept of friction, the concept of static and kinetic friction. So kinetic friction will always be acting. Let me just go back to that differentiation table. Yes. So kinetic friction will always be acting when there is a relative motion between the two bodies. Static friction will always be happening when there's a tendency of relative motion. I hope you guys can understand. So for static friction there is no formula, but there is a formula for F limiting, right? So F limiting will be given as nu s times of n, right? When nu s is actually equals to your coefficient of static friction. Yes or no? Very similarly, when I talk about kinetic friction has a formula, right? Fk will be given as nu kinetic times of your normal reaction, where nu k is basically your coefficient of kinetic friction. I hope that is understandable to everyone, right? If you have any doubt, you can comment it down and ask me, right? So that's all for today. Thank you and have a nice day.